Crabs. Placed on an island by scientists years ago, their growth and successful family tree has been propelled by their unrestricted access to food. With weeks turning to months and subsequently years, the crab situation has worsened, and the island is left with an evergreen reality plagued by crabs. In a final attempt to fix the situation, mathematicians and crab experts alike were called to help provide their expert assessment of the situation. This is the story of their prospects.
Past 5 years, I've been studying this crab's every action. From their arrival in 1990 to their annual growth, it's been a meticulous act to keep track of their daily routine. But I can say I understand almost everything about these animals, except, that is, their mating cycles. That's the only thing I don't understand. Gosh, man, I wish there were someone that could help me out.
My name is Miles Harper. I'm the lead researcher at the new island that we're studying the crabs on. So the crab is a species that's very rare. It's called the Christmas Island red crab, known for being native to the Christmas Islands in the middle of the Pacific Ocean. And because they're such a small island and they're such a very rare species, it's very dangerous when they become endangered because there's nowhere else we can get a second population from. So because of their location, it's very dangerous to have them get at such a level, which is why we put them on their own island and allow them to regrow their populations. So biology-wise, the red crabs live for around 4 to 5 years, and they reproduce every year around October to November. That's the beginning of the wet season over on the island. But because crabs are normally giving birth to thousands and thousands of other crabs, their growth should be a matter of 1 to 2 years, right? But this crab on the Christmas Island, there is an invasive species that was introduced from Africa called the yellow crazy ant. And because this ant likes to eat the larval stage of the crab's babies, they have an extremely low birth rate, which results in a much longer experiment. So out of the 1,000 crabs that are hatched, around 2 or maybe even 1 would make it out alive and develop to maturity.
My name is Kevin Ling, and this is my partner, Rusty Luke. We're the two fellow mathematicians that the scientists brought on this island to help them calculate the population growth of this crab species. We've both gone to very esteemed colleges because great at math, and we were brought onto this research to help with all of the problems because we have such high regards. So, based on the information we received earlier from the scientists, we know that this graph would be an exponential graph. So, based on the information we were given from the scientists, we could form an exponential graph in this. So, our graph is f of x, which will represent the population after a certain amount of time, is equal to 2 to the power of x plus 1. So, every year we have observed that there has been a population increase of at least 1 per year. So, from this, to help us with our graph, let's make up a t-table. So, we have our x and our y. And we can start off with a few basic numbers. Let's plug in our first number, 0. 2 to the power of 0, which replaces the x, plus 1. Now we know whenever a number is to the power of 0, it equals 1. 1 plus 1 equal to 2. So that means after 0 years, we have 2 crabs. Now let's move on to our next number. 1, 2 to the power of 1 plus 1. We just left with 2 plus 1 means we have 3 crabs after 1 year. So now I would like to let my colleague Rusty Luke do the rest of the math for us. Thank you very much. Alright, so our next x is going to be 2. So it's 2 to the power of 2 plus 1. 2 to the power of 2 is 4. Plus 1 equaling 5. So there's 5 crabs after the second generation. Now we're going to go to 3. 2 to the power of 3 plus 1 equals our y, or f of x. So 2 to the power of 3 is 8, because 2 times 2 is 4, and times 2 again is 8. Plus 1. Add 1, making it 9. After 3 years, there will be 9 crabs. So the reason why we use a base of 2 is because we started out with 2 crabs to begin with, and the reason why we add 1 is because if you see it on a graph, 2 to the power of x will always start at 0, 1, so we want to add 1 to the y, so when we begin, we start at 2. If you see on the graph, the domain will come 0 to infinity, meaning that as long as the crabs have their resources and food to allow them to keep growing, they can exponentially grow forever. But there's also a reason for the growth being very small, and that is due to their invasive species that is hurting their population.